Hey, Algebra 1. Today we're going to look at a couple word problems that deal with solving inequalities. Okay, so make sure you have a pencil, paper, and a highlighter to look over these problems here. Looking at number 1. Okay, number 1 says a music teacher grades on an E for excellent, S for satisfactory, and U for unsatisfactory grading scale. A final score of more than 90 earns an E. Final score of 60 or less earns a U. Any other score earns an S. Okay? Write two inequalities, one to represent a grade of E and one to represent the grade of U. Okay? Keywords here is that a score of more than 90 earns an E and a score of 60 or less earns a U. Okay? So to get an E, you would have to earn a score that's greater than 90. Okay? The reason being is that it just says more than 90. Okay? So any time a score of more than 90, a student gets a score of more than 90, they get an E. Okay? For a U, it says 60 or less. So that means we include 60 here. So a U would have to be less than or equal to 60. Okay? All right. Looking at the second example, once again, I'm going to go through these each one at a time. Okay? So use the chart to answer parts A through C. Okay? So we have only A and B here. I don't know where C went. That's okay though. I'm sure it has to deal with main here. So looking at for part A, it says write a compound inequality for the range of the temperatures in Illinois. Range is going to be 70 to 75. So we want to write a compound inequality. In this case, because it's a range, it's going to be an and inequality. So we're going to have 70 less than or equal to, let's use T, less than or equal to 75. And the graph for that would just basically be this. If I have a number line, 70 on the left, 75 on the right, close circle in between both of them, because if it's a range, we want to include those numbers in there as well. Okay, and then our compound inequality for the range of temperatures in Texas. Well, Texas is 80 to 85, so that's going to be another and inequality. So we're going from 80 less than or equal to T, less than or equal to 85. I don't know why I keep wanting to write sevens, but 85. And very similar to what we saw for Illinois, but we're going to have 80 here and then 85 on the right. And then once again, we're going to include those. So that means we have everything in between. So any number between 70 and 75 for Illinois, 80 and 85 for Texas, that gives me a range of the temperatures that we can have. Okay. Second example. Table shows the cost of various items at a farmer's market booth. Kelly wants to buy 1 pound of blueberries and several pounds of grapes. She has $16 to spend. Write an inequality to represent this situation, then solve the inequality. Okay, a lot going on here, okay? There's even a lot going on in the table. So let's kind of read through this again, so that way we know what we need to pay attention to here. So it says that Kelly wants to buy 1 pound of blueberries and several pounds of grapes. Okay, and she has $16 to spend. All right, so with 1 pound of blueberries, we're going to look at this and this cost here. And she says that, or the problem says that she wants to buy several pounds of grapes. Several can imply any number here, so we're going to just highlight the grapes here. We don't know how much she's going to spend, but we do know that she only has $16. Okay, so when I solve this equation, or more so an inequality, we have to write it first. We want to know that she's spending money on grapes and blueberries. So in this case, the number of grapes she has that she's going to spend on grapes has to be a cost per pound of grapes. So let's say it's just 6x, because we don't know how many pounds she's solving or she's going to be able to buy, but we know that she wants to buy a lot of it. And she only buys 1 pound of blueberries, so that's going to be easy. We just add 5 to that. Now, because she only has $16 to spend, that means she's limited to that much. So we're going to throw in a less than or equal to 16 to represent how many grapes she can actually get. So we go ahead and solve this. Subtract 5 from both sides of the inequality. That subtraction property of equality still plays into this. Combine my 5s, I'm left with just 6x less than or equal to 11. Okay, I'm going to write this over here so we have some more room. 6x less than or equal to 11. Go ahead and divide by 6. I'm left with x is less than or equal to, if we represent this, it would be 1.333 repeating. Okay, so that represents how many pounds of grapes she can afford to pay with only $16. Okay, and ignoring tax and all that, of course. What does your solution mean in the context of this problem? It means that Kelly can purchase up to 1.8333 pounds of grapes. Okay? You guys ever go to the grocery store? Basically, that means that you guys know you're not always going to get exactly 1 pound or exactly 2 pounds. There's always some sort of decimal that you have to deal with. So you can buy 1.8333 pounds of grapes. It's just that when it rings up, hopefully it's no more than this. Otherwise, she's going to run out of money to spend there. All right, another example here. Easy Music Downloads has 2 plans available. The pay-as-you-go plan, which costs $1 per download, and the prepaid plan, which costs $20 a month, plus 50 cents per download. Write and solve an inequality to represent the number of downloads required for the prepaid plan to be cheaper than the pay-as-you-go plan. Okay, we want to be able to model these using algebra. Okay, in this case, our variable is going to be the number of downloads. Okay, let's use D, a lowercase d, to represent that. Okay, so the pay-as-you-go plan, so P-A-Y-G, the pay-as-you-go plan, it's $1 per download. We're going to call that just 1 times D. Okay, and then the prepaid plan, so prepaid plan is $20 plus 50 cents per download. That's how we write that, okay? So we want to write an inequality that represents the number of downloads required. Oh, I forgot, not P, it should be D. Let me try that again. Okay. So we want to represent the inequality that represents the number of downloads required for the prepaid plan. So this guy over here to be cheaper than the pay-as-you-go plan. So this expression for the prepaid plan should be less than the pay-as-you-go. Okay, so that's going to be 20 plus 0.50D less than, or should be less than 1D. And the only reason we want less than is because we want it to be cheaper, not the same. Okay, so I'm going to solve this like it's a normal inequality. I'm going to subtract 0.50D from both sides. All right, when I do that, I'm left with 20 is equal to 1D minus 0.50D. Well, that's just going to be half. So 0.50D, divide both sides by a half. I'm going to be left with 40 less than 1D. Or if I rewrite it where D is on the left side, it would be D is greater than 40. And what this means here is that in order for the prepaid plan to be cheaper than the pay-as-you-go plan, I would need to download at least or more than 40 downloads. So I have to be downloading songs more than 40 times in order for it to be cheaper. All right, number 5. Roy is attending his cousin's graduation ceremony in another town. Roy has already driven 40 miles, and the ceremony starts in 3 hours. Let R represent Roy's driving speed in miles per hour. Write an expression to show the total distance Roy will have driven in 3 hours. Okay, so here's how this is going to work. It's kind of like a distance equals rate times time here, okay? So we don't know the rate, but we do know that he has 3 hours to go, and he's going a certain rate. So that gives me a distance. Plus, he's already driven 40. Okay, so that means that he's got to be able to get there in 3 hours. Plus the fact that he has he's already driven 40 miles. Okay, so the graduation is 220 miles from Roy's home. Use this information and your expression from Part A to write an inequality showing the possible speeds Roy could drive to make it to the ceremony on time. Okay, so we're going to relate 3R plus 40 to this 220 miles that he still has to go. Okay, now obviously we want him to be there before the graduation ceremony starts. Okay, so in this case, his rate needs to be greater than a certain speed. It needs to be faster. So we're going to say he has to drive something faster. His rate needs to be a little bit higher to get there. So when we go ahead and solve this, like we should be for Part C, we're going to do subtract 40 from both sides of the inequality. We're left with 3r is greater than or equal to 180. And if we divide everything by 3, that means that r needs to be greater than or equal to 60. Okay? So in this case, what this really means is that Roy needs to drive at least 60 miles an hour or faster in order to get there on time. I hope he doesn't get a speeding ticket at that rate. So otherwise he's going to be really far behind and he probably won't make the ceremony. So, all right, guys, your homework, because we're getting to the end of the unit here, is a benchmark review on Google Classroom. Make sure you come to class, our next class, with questions on that review, and I'll talk to you guys then. Have a good one.